If you exceed the tipping point, within 30 to 50 years, we are going to lose between 50 and 70% of the forest. We may reach the tipping point by 2050 if we continue the way we're doing deforestation and global warming. If we were able to get to zero deforestation, there are many thousands of species we call secondary forests. They grow so fast, but we have to get zero deforestation and then to create a large-scale forest restoration.
Today's guest is Carlos Nobre, an earth scientist from Brazil who is currently a senior researcher at the University of Sao Paulo, with his work primarily focusing on the Amazon jungle and its impact on the Earth system. Carlos is also the co-chair of the Science Panel for the Amazon, and he was formerly the chair of the large-scale Biosphere-Atmosphere Experiment in Amazonia. He's also a member of the British Academy of Sciences as well as the World Academy of Sciences. Through his work on the Amazon, Carlos has also developed the Amazonia 4.0 initiative, an innovative project to demonstrate the feasibility of a new socio-bioeconomy of standing forests and flowing rivers in the Amazon. This is the first of several interviews I have focusing on the critical importance of maintaining the forests in the Amazon, how close we are to long-term tipping points flipping into a savanna, and what people in Brazil and what people in the world need to do to forestall and eliminate these risks. Carlos joins me to discuss how the Amazon is a foundational system, not only for regional ecosystems in South America, but for global weather systems and the entire biosphere. I hope you learn and enjoy this conversation, enjoy in quotes, with Carlos Nobre. Carlos Nobre, welcome to the program.
Thank you. Thank you very much for the invitation.
Thank you for your lifetime of work on the Amazon and the situation in Brazil and the forest. I really want to understand what's going on with the tipping points, with the Amazon forest, with the relationship with climate change. I want to get to all those questions. I have so much to ask you because you're the first guest that we've had on the Amazon. But first, how did you get started in this? I remember reading your warnings about the Amazon long ago. How did you get started in this work?
Well, I started a long time ago. In fact, I graduated as electronics engineer, 1974, and then I looked for a job in the Amazon. So I went, found a job there, the Brazilian Amazonian Research Institute, and I was working as an engineer there. But I really was in love with the Amazon. And that time, 1975, only 0.5% of the Amazon had been deforested.
So 99.5 was still intact.
Yes, 99.5. And then when I was there, the director of that institute said, Carlos, why don't you go to do a PhD? You should become a scientist. So I was excited. And then I came here to the US. I did my PhD at MIT, 77, 82. And then I went back, found a job in southeastern Brazil, but I dedicated from, let's say, January 1983 up to today, most of my research is related to the Amazon. And of course, from 1975 to today, the Amazon is in a great, great risk. So I've been doing a lot of research about the Amazon.
How many times have you gone into the forest itself? Hundreds of times, yes?
Yes, hundreds of times. I mean, when I was younger, also, I was doing field research in the Amazon. There were times I spent 1.5 months in the field research in the forest. So now I go many times to the Amazon, but less than 30, 40 years ago.
So we're going to get into some data and charts and statistics, but what are like one or two of your key memories in the Amazon, or your favorite animal or creature that lives there?
Of course, I mean, when I was there in the Amazon doing the research in the forest, oh boy, it was beautiful to see the biodiversity. I've seen jaguars, hundreds of bird species, and also the beautiful rivers. a lot of fish. So, it was interesting to be there and seeing. I think I've seen more than 500 different animals during my visit to the Amazon. But of course, my research was not only in the forest. What happens when you deforest? So, for instance, we install many towers, 50 meters tall towers in the forest and 20 meters in the pasture, livestock farming, cattle. And it was quite interesting because in the forest, I would see hundreds of animal species. In this pasture, only cows. No, the biodiversity, that pasture is not the ecosystem, the evolution of millions and millions of years. So it was very interesting to see how biodiversity would be affected if we continue deforesting the Amazon.
I have so many questions. So you just mentioned the millions of years. How old is the Amazon, and how did it evolve over time, briefly?
Yeah, when you look at tropical forests, that's more than 100 million years. However, the climate in the Amazon, as we know today, it really was just really became a reality after the Andes Mountains were coming up, uplifting. It started 40 million years ago. 5 to 7 million years ago, it was the final. So once the Andes were there, so the climate changed in the Amazon, much more rain, so the forest extended. So I would say 10, 20 million years is the more recent forest. And that's an important evolution because the climate is so stable and the forest evolved also interacting with the climate. So it's not only large scale climate. No, the forest interacts with the climate. The forest is very efficient in recycling water. So this recycling of water in the Amazon, 30 to 40% of rainfall depends on water recycling.
30 to 40% of rainfall in the Amazon or elsewhere?
No, in the Amazon. Near the Atlantic coast is less because there's a lot of moisture coming from the Atlantic Ocean. It's about 20%. But when you are close to the Andes, over Western Amazon, 50% of the rainfall depends on the recycling of water.
Well, that's why they call it a rainforest.
Yeah, of course, I mean, totally 2.2, 2.3 meters of rainfall per year.
2.3. Wow. Yeah.
Over Western Amazon near the Andes, this is more than 3 meters. And there is a very efficient recycling of water. This is a unique evolution of the Amazon forest. For instance, that's the only forest in the planet that you have more water transpiration by the plants during the dry season than during the wet season.
How does that work?
Okay, that's very important evolution. There is lots of rain during the wet season. The dry season, historically, it's 3 to 4 months, but still there is rain during the dry season. For instance, the driest month in southern Amazon, the rain is 50 millimeters. So what happens is during the wet season, there's tremendous amount of rain. The ecological evolution in the Amazon transformed the soil. So the soil absorbs a lot of water. So it's not like, rainfall and the water run off to the river. So it absorbs, goes deep up to 7, 12 meters. And then 1/4 of the trees evolved also with deep rooting system that goes all the way to 7, 12 meters. So during the dry season, there is less solar radiation because there is less cloudiness. So there is more energy for transpiration of the plants. And these deep roots, they pull the water, but not only through for the trees there. They also distribute the water near the surface, so the other trees are fed with this water. Then transpiration of the plants is more. Just to give you some figures, during the wet season, the transpiration is 3 to 3.5 liters of water per square meter per day. During the dry season is 4 to 4.5 liters of water.
Because the environmental conditions are drawing down the water bank that's in the soil that was built from the prior season.
Yes, of course, the most of the trees have shallow rooting systems, but as I said, 1/4 of the trees are very deep. So this is very ecological evolution. And the science shows very clearly because, let's say, in most of southern Amazon, dry season was June, July, August, September. And at the end of September, the transpiration was so high, the end of the dry season, that the moisture would reach the atmosphere at a very fast rate, and that was the transition towards the wet season. So that's an ecological evolution, very important. Also, from the top of the forest to the floor, the difference is 30 degrees maximum temperature and 26 degrees at the bottom and the soil. So those are the ranges of temperature of maximum photosynthesis. This is ecological evolution. So the forest moved towards creating the ecological evolution for maximum photosynthesis. So this is very important.
This has been stable on its own. It's its own stable ecosystem outside of the global climate situation. So they're intertwined, right? So how does this water system in the Amazon affect global weather and climate patterns from what you just described?
Well, of course, it's very important because, over the tens of millions of years, the Amazon forest removed a large amount of carbon dioxide from the atmosphere. Today, there is about 150, perhaps even close to 200 billion tons of carbon. This is
Stored in the trees.
and in the soil. So, of course, this is very stable for maintaining the temperature at a certain value. As I said, this optimal photosynthesis. If the temperature reaches 43 degrees, it's zero photosynthesis on the leaves. So it's very interesting ecological evolution for tens of millions of years. Never the temperature in the Amazon reached that. And of course, removing carbon dioxide from the atmosphere becomes also very important, not to let global warming, at least for tens of millions of years. That's the evolution. So this is also very important factor, really, to maintain those temperatures, not 43 degrees, not very cool. Also, when it's very cool, there is no photosynthesis.
But I've read somewhere that what happens in the Amazon actually significantly affects the weather patterns in the United States, for example. How does that work?
Yes, there is some recent research now. The first thing I mentioned is importance of removing carbon dioxide from the atmosphere. But of course, as I said, this 2.2, 2.3 meters of rainfall a year. What's rainfall? I mean, you have water vapor that goes up the atmosphere. So they use, as I mentioned, most of the solar energy for evaporation. The water is evaporate. And when there is condensation to create the cloud droplets, so that energy is released. So that warms that atmosphere, that keeps the pressures there, low pressures. What some recent studies were showing is that if we lose the Amazon, then we reduce not less than 30% the rainfall all over the Amazon basin. And then that reduction of the rainfall, so as I said, with the evaporation, condensation, release of heat, so it creates a system of low pressure. And this low pressure also draws much more water vapor from the Atlantic Ocean. If you decrease 30%, 40% rainfall, so this low pressure system changes a lot. it becomes higher pressure, and this will start atmospheric wave, starts in the Amazon, moves to the north, and this is a wave, low, high pressure, and it will reach low the border of US, Mexico, and then high pressure over western US, around California. So these studies indicate if we lose the Amazon, parts of the California will become even drier. It's dry, most of the central, southern California. So that would be one of the impacts of losing the forest.
When you say losing the forest, what do you mean by that?
Unfortunately, the Amazon is very, very close to what we call a tipping point, quote unquote, savannization. The forest, as I say, keeps tremendous amount of carbon. The forest is so dense with trees, with leaves. Just to tell you, the top of the forest absorbs 96% of solar radiation. Only 4% of solar radiation
hits the ground.
Reaches the bottom.
Wow.
So
unless you're in a pasture, then
yes, unless you're in a pasture. I'm saying the forest. Yeah. That's a tremendous ecological evolution. Why this evolution? This is really something very good, because unlike sequoia forests in western US or boreal forests in Canada, because there is so little solar radiation reaching the forest floor, it's very wet. So there is not much solar radiation for evaporation of the soil water. So that's so wet. So the trees, the trunks, the branches, the soil is so wet. So ecological evolution of millions and millions of years, lightning strikes. So there is a lightning strike. It ignites a fire everywhere in the world. But because everything on the bottom of the Amazon forest is so wet, when the vegetation is very, very wet, it's not flammable. So when there is a lightning strike, maximum it will lead to 1, 2 trees to die. That's it. Does not expand. So this is ecological evolution, very important for the Amazon forest.
And it's created stable conditions, which we are now disrupting. Before I came here, and I'll post this for the viewers, I looked at a aerial picture of the Amazon today, of all of South America, and the smoke is like almost the size of Brazil on the western side of South America. So we're in a drought right now, second year in a row. Is the soil still wet? Is it still 96%? Are the conditions changing rapidly, or what can you tell us?
Yes, unfortunately, because of global warming. Before global warming, we would have one severe drought every 2 decades. And for millions of years, we would have a very severe drought every 200 to 1,000 years. In this scale, 200 to 1,000 years, yes, there will be a severe drought. Part of the Amazon forest will become very dry. And when there would be a lightning striking that dry forest, then a fire would really destroy sometimes 4,000, 10,000. There are studies showing even 15,000 square kilometers. But that was something once every 1,000 years. Now, before global warming, we're talking about one more severe drought every 2 decades. Now, 2005, 2010, 2015, 16, and record-breaking drought in the history of Amazon, 2023-24. So that's global warming. Global warming, science has predicted that for many decades. I'm always worked in that. We are predicting global warming would induce severe droughts. What's the driver of these severe droughts? 2, the Equatorial Pacific El Nino phenomenon. El Nino phenomena are becoming much stronger. For instance, 2015-16, the record-breaking El Nino in strength. 2023-2024, the third largest El Nino. And so they induced drought in the Amazon. But this is historic for millions of years. But now, 2 droughts per decade. So that's bringing a tremendous imbalance to the forest. The elements that we are saying about the tipping points. I was the first scientist almost 35 years ago. I published the first scientific articles in 1990 in Science, in 1991 Journal of Climate. Then I came here, spent 1 year at the University of Maryland. We did that study, but that was 1990s. There was an increase in deforestation. So I decided to do that research. What is going to happen to the Amazon forest if deforestation becomes very large?
In 1990s, it had gone from 99.5 down to what in the 1990s, the amount of forest cover? You said it was 0.5 when you first got your PhD.
1989 was 7%.
Okay.
Yeah. So my calculation did, if you have a large-scale deforestation in the Amazon, the dry season over southern Amazon would reach 6 months. The ecological evolution when in the tropics, when you have 6 months dry season, this is the tropical savanna. That's the ecological evolution, tens and tens of millions of years. So my study show if we deforest the Amazon a lot, all southern Amazon would become a degraded savanna. I said that, I created the quote-unquote savannization of the Amazon. But that was a projection in the future. So unfortunately,
you were right.
I was right. Not only because that was one study. You remember, by 1989, when I was at the University of Maryland, still we are not talking much about the risk of climate change. The first IPCC report came in 1990. I was part of that. The first COP 1993, the ECHO 92 meeting in Rio, all those things. So at that time, I only look at deforestation. And then myself, my PhD students, we put together deforestation, global warming, etc., etc. We published many, many studies. In a study we published in 2016, we put deforestation and global warming. And then our studies show if deforestation exceeds 2025, and global warming 2.5 degrees, we will really go to the tipping point in the Amazon, impossible to revert. So today we are at 18% deforestation. And we are, unfortunately, as you know, for the first time in 120,000 years, the temperature reached 1.5 degrees 2023, continuing 1.5 degrees. So we are at the edge, and and it's not only a projection. The data are showing we are at the edge. Why? Because the dry season over 2.3 million square kilometers, all southern Amazon, is 4 to 5 weeks lengthier in 40 years. 1 week longer per decade. So in 2-3 more decades, it reached 6 months. Impossible to maintain the forest. Second, southeastern Amazon is one of the only forests in the planet. The Amazon forest, has become a carbon source. Globally speaking, all forests remove 32% of all carbon dioxide emissions on the planet, our emissions. The 1990s, the Amazon forest was removing 1.52 billion tons of carbon dioxide. Still, the forest removes. However, that part, the forest has becoming a carbon source, tremendous tree mortality. So when we look at all those figures and also highly deforested areas in southern Amazon, the temperature is 2-3 degrees warmer. So all of southern Amazon is at the edge of the tipping point.
So the whole Amazon forest is not yet a carbon source, but part of the forest is.
Yes.
And what happens if we go through the tipping point, if we get to 20% of deforestation and 2 degrees Celsius? What tips, and then does it just really go fast after that point.
Yes, if you exceed the tipping point, then there is a self-degradation, continuous self-degradation, and many studies show within 30 to 50 years, that's impossible to stop that degradation. And within 30 to 50 years, we are going to lose between 50 and 70% of the forest. Only near the Andes, because near the Andes, the rainfall is more than 3 meters. Even reducing the rainfall, but still it's sufficient. And there is almost zero dry season, even if there is a little bit of dry season, but still that climate will be consistent with the forest. But this is perhaps 30% only. And a recent study we published in Nature showing we may reach the tipping point by 2050 if we continue the way we're doing, deforestation and global warming. At some moments, we could see a little bit of some good news when Amazonian countries were able to reduce deforestation. But unfortunately, in the Brazilian Amazon, we had a good reduction of deforestation from 2005 to 2012. We are really moving towards much less deforestation, but then unfortunately increased a lot 2015, 2022. We are very concerned because this is, let me tell you, another big problem. I know it's not a scientific problem, but it is a political problem that all over the planet there is an increase in the populist politicians all over the planet. Why? I'm not a scientist. I cannot answer that question. It's hard for me.
Well, you are a scientist. You're not a brain scientist or social scientist.
I'm not a social scientist. I mean, I don't understand why. And this is far right wing and far left wing.
People don't want to hear these uncomfortable truths. They want to hear nice things.
Yeah. So, yeah, I heard about that, but it's hard why people accept these populist politicians, because Brazil and many Amazonian countries had populist politicians. Fortunately, now we don't have anymore. But these populist politicians, they were totally in favor of disappearing the forest. Forests have no value. So that's, fortunately now, 2023, 2024, for the first time in 11 years, we got a large-scale reduction of deforestation all over the Amazonian countries, 50% 2023, and continued reduction 2024.
So there's still deforestation, but it's just growing at a smaller level? Is that what you mean?
Yes, much smaller level. And also, almost all Amazonian countries, we had Amazonian Countries Summit in August 2023 in the Amazonian city of Belém in Brazil. And the countries, almost all countries, sign agreements to get to zero deforestation by 2030. So most Amazonian countries are moving very quick. For instance, in Brazil, from January 2023 to July 2024, we got 64% in the reduction in deforestation.
So if you were a benevolent alien scientist that was hovering above the Earth and looking at what's unfolding on our planet, you might logically conclude that the Amazon forest is one of the natural wonders of this planet and that it has a special role in the health and stability of the conditions of the Holocene. Would you agree with me?
Yes, yes.
Yeah. So given what you just said, there's at least two core dynamics. One is Brazil and the countries that have the Amazon have a role to play in limiting deforestation and keeping the health of the evapotranspiration and that whole cycle. But the rest of the world has a responsibility with respect to climate change and emissions to limit those or keep those down so that Amazon doesn't go into the tipping point that screws up the weather system for the whole world. Is that correct?
Absolutely correct. We are so concerned because, as I said, almost all Amazonian countries said zero deforestation, degradation by 2030, and also very important forest restoration. We are starting large-scale forest restoration projects in the Amazon. However, of course, reducing emissions from the Amazon deforestation, it's very good. Forest restoration will remove also carbon dioxide from the atmosphere, but that's not sufficient to avoid the temperature continue to go up. For instance, not even the science predicted that we would reach 1.5 degrees warming by 2023.
Yeah.
Science was saying 2023 might reach 1.3 because we had 1.2 in 2022, and then a very strong El Nino. So then all of a sudden, 1.5 continues 1.5. This El Nino disappeared in May this year, continued warmer. August was the warmest year in 120,000 since the last interglacial period. So there is a tremendous risk if, and we are talking a lot, thousands of scientists are trying to explain, if we maintain 1.5 degrees this coming year, 2025, and then science may say, I'm not saying science is saying that, I say, if we continue 3 years with 1.5, the science may say we reach 1.5. And we're still increasing emissions, all greenhouse gases. If we reach 1.5 now, and we continue, if we go to COP26, they say, in Glasgow 2021, not to exceed 1.5 globally, we have to reduce 43% emissions by 2030 and get to net zero by 2050. However, if we reach 1.5 now, if we do that, we may reach 2.5 by 2050, not 1.5. So that's why it's a tremendous risk for the Amazon as well.
Okay, I have a lot of questions here. So you mentioned lightning strikes historically, and they burn a few thousand acres. But lightning strike is not what's causing most of the fires now, is it? It's
No.
conscious people burning them, right?
Unfortunately, historically, since Brazilian government dictatorship in 1970s decided to go and get rid of the forest, they had the tremendous ideas that from the colonizers from Europe that came 500 years ago. Tropical forests are places of the hell. Even, a lot of books in the 1970s, 80s, they call green hell to red deserts, because, the military had this impression that they had to get rid of the forest. Since 1970s, they start going deforestation, deforest, let the trunks there dry out for 2 months and sets fire. Then they use, all the things that come from all those elements. They are really the fertilizers for a very poor soil. So then grow a pasture, brings the cows, cattle ranches. However, unfortunately, now we had the record-breaking fires in the Amazon, 2023, 2024. Yes, you can say, well, this is also due to record-breaking drought, heat waves. However, we now are seeing that almost all fires are criminal fires. They are organized crime in the Amazon, setting fires. Why? Because there was a tremendous reduction of deforestation. So deforestation was part of their business, all illegal.
Oh, so we did deforest, but the boomerang effect, these people have to make a livelihood somehow, so they're setting fires to start other businesses with farming and fertilizer and such.
Yes, because there was this tremendous reduction of deforestation. In the Brazilian Amazon, in Colombian Amazon as well, 90% of the deforestation is illegal.
Can it be enforced, or is it just too far distant and there's not the ability to enforce it, to punish the people?
There should be abilities to enforce. However, in the previous government in Brazil, the former president, also a populist politician, far right-wing politician, was encouraging everybody to deforest. So now, with the current president in Brazil and most Amazonian countries, they are combating. So that's why I say a great reduction, 64% reduction in Brazilian deforestation. So the organized crime, which for decades they were doing deforestation, because the satellite monitoring systems detect the deforestation immediately. The geostationary system sends data every 10 minutes. So to deforest, they have to get people there. They are there for days to weeks to deforest, 100 hectares, something like that. So the satellite is monitoring. The law enforcement agencies are receiving that data. So that's one of the reasons, reduction of deforestation.
The Amazon is really important to the world. So it's almost like its jurisdiction is within Brazil and the countries around it, but it's necessary to the stability of the world. So couldn't the world help with funding or technology or something to not only reduce deforestation and some of this illegal activity, but help Brazil reforest? You said there's a 64% reduction in deforestation, but that's still deforestation. We have to get to reforestation, right?
Yes.
So doesn't the world have a responsibility to help with this? What are your thoughts on that?
Absolutely. Absolutely. For instance, Brazil launched at COP28 a project of restoration. It's called Arc of Restoration. It's to restore 24 million hectares in the Brazilian Amazon, mostly southern Amazon. The forest degraded, and the estimate cost is $40 billion. Brazil wants to do that from now, 6 million by 2030, 18 additional million hectares, 2030, 2050. In fact, for the whole Amazon, we need to restore much more, all Amazonian countries. Let's say, ideally, 1 million square kilometers. There are 2 million square kilometers, 50% deforested, 50% degraded. The estimates of the cost to do that, $150 billion. But that would remove tremendous amount of CO2, would protect biodiversity, would also really combat the tipping point, because this forest restoration will recycle water, lower temperature. So, this $150 billion, well, that's nothing. Certainly all countries, for instance, the Green Climate Fund, it's only $100 billion a year. It should be much more. Many countries, like my country, President Lula and many others are saying we should create these funds, but they should reach, people say, actually for saving all forests, the planet, all ecosystems, not only the tropical one, we may need $1 trillion a year for all the planet. So that's what I'm saying. It's very important for developed countries to support, because really, and even for 1 million hectare, 1 million square kilometers in the Amazon, that will remove 1.2 billion tons of carbon dioxide per year.
The irony is $1 trillion. We need that wealth from a fossil fuel-based economy in order to save the impacts from the fossil-based economy. But let me ask you this. Let's just do some bookend speculation here. What would happen to the rest of the world if there were a partial or total collapse of the Amazon forest? Just assuming that climate stays where it is, just the loss of the Amazon, what would that mean for the rest of the Earth's weather, natural systems?
Tremendous risk. If we cross the tipping point, and then it will be within 30 to 50 years, 50 to 70% of the forest will degrade. So that will mean emissions of 300 to 350 billion tons of carbon dioxide
that were stable or a sink and now are a source.
Yeah, it will become a big source. Only that emission may make it almost impossible to maintain the global temperature 1.5 degrees. However, a tremendous risk, in addition to this climate risk, is biodiversity. The Amazon forest has the highest biodiversity on the planet. Science knows 13% of all plant and animal species. For instance, 16,000 tree species are known in the Amazon, 50,000 plant species, 3,000 fish species, etc., etc.
So those were nature's solutions over time.
Nature solutions. But there is a tremendous risk for ourselves, humans, because for the first time since the colonizers came to South America 500 years ago, now, 2024, epidemic. The science shows more than 25 zoonoses, virus, coronavirus, hantavirus, arenavirus, that they were there. They became zoonoses because of the degradation that we put the forest. And unfortunately, for the first time now, one of these viruses became an epidemic in Brazil. This year, 14,000 Brazilians caught that disease. It's a virus. There's a Spanish name, Oropushi virus, and one insect is transmitter. So, and the infected people are not only in the Amazon, all over Brazil now. So it's spread. So far, it's epidemic. And the studies show more than 25 cases of zoonosis. And many scientific studies show if we degrade all tropical forests, we are going to have 1 to 2 pandemics per decade in the planet, like COVID. So that's another. I'm just saying, of course, maintaining the forest, if we lose the Amazon, there's tremendous risk. And okay, that's the second on biodiversity. And the third one is the other ecosystem service, very important, which is the Amazon recycle water so efficiently that it really exports a tremendous amount of water vapor south of the Amazon. This is the Amazon River flows into the Atlantic Ocean, something like 18 billion tons of water per day. The so-called flying rivers or aerial rivers, it's 17 billion tons. So that feeds all the rainfall systems in Central South America, even in Southeastern South America, Uruguay, Paraguay, parts of Argentina, Southern Brazil, and particularly Central Brazil. The biome in Central South America is tropical savanna, an evolution over 40 million years since the Andes started uplifting. And so the studies are showing even this tropical savanna will become, at least 50% of the tropical savanna will become semi-arid type of vegetation.
So if we lost the Amazon, how long would it take over evolutionary time to recover? If we go through the tipping points, do you have any knowledge on that?
Well, that's time? Very, very serious, because if we reach 3-4 degrees warming in the planet, so we are going to lose the Amazon. And then, because if we, also there are more than 20 tipping points. The Amazon is one of them. The other one is permafrost.
Yeah.
If we exceed 2 degrees, you interview Joran Rockström. Certainly, he told you about the risks of melting the permafrost. We are going to lose more than 200 billion tons of greenhouse gases. So if we do that, then the temperature may go 3-4 degrees. And then the planet will be very hot for thousands of years. Thousands and thousands of years.
Or longer.
Or longer. It's funny because some climate change deniers, they say, oh, this is very good because we are going to make
more CO2 is good for plants.
No, they say it's good for plants, no question about that. However, they say other things. They say we are going to avoid the next glacial, but glacial is 20,000 years ahead. So, but this is ridiculous because then you lose most of the biodiversity in the planet. If the temperature reaches 4 degrees, 5 degrees, we are going to start the sixth species extinction on the planet.
Well, or we've already started it, depending on your definition.
For instance, as you know, coral reefs, we are seeing that.
Yeah.
We are seeing a lot of other species. So it's ridiculous that if we reach 4 or 5 degrees, this starts the species extinction. And yes, I mean, studies show if the CO2 concentration in the atmosphere reaches close to 600 parts per million, now we are reaching
430.
430, close to 430. So if we reach 600, so not even the next glacial. So you see, this is it's the 6 species extinctions, and also for us.
I had Corey Bradshaw from Australia on recently, and he said at 3 degrees Celsius, we lose 50% of the species on Earth.
Yes.
So let me ask you a different question. If for some reason we totally left the Amazon alone right now, I know that's a hypothetical, how long would the evapotranspiration cycle, the photosynthesis to grow back, how long would it take to get us back to the level when you started your PhD from a 17% drop to recover most of that?
Let me tell you, if we were able to get to zero deforestation, degradation, then fortunately, the evolution of the tropical forest over tens of millions of years is fantastic because the secondary forest, there are many thousands of species we call secondary forests. Those are the species that grow like crazy. I mean, they grow so fast. They grow, for instance, the secondary species may reach 7, 10 meters in 2 to 3 years. And they recycle water. So the secondary forest species make the forest to function very well, decrease the temperature, recycle water, and then, of course, they grow very fast. And within 15 to 30 years, then the primary forest species, they start growing also not very fast, but they grow. And after 50 years, you have a primary forest again. So this is ecological evolution of the Amazon. And that's what I'm saying. You don't have to wait 30 years. Immediately, 3 years later, the forest is already doing all those ecological services. So, but we have to get zero deforestation and then to create a large scale forest restoration. And also, unfortunately, because there are areas with very large deforestation, let's say there are one area with pastures there, and the nearest forest is 30 kilometers. So unfortunately, in that natural regeneration is very slow.
Is there a synergistic ecological impact from the distribution of the forest versus pasture patches? Like if it's kind of cookie cutter, forest pasture, forest pasture, forest pasture, it loses the ecological function, and it might be better if you have the same amount of pasture and the same amount of forest, that they're clumped together. Is there something going on there or not really?
Well, there is a lot of research which is called regenerative agriculture.
Mm-hmm.
And the regenerative agriculture also has livestock farming, but then you have a small area with pasture, and you have around that area the biome, let's say the Amazon, the forest. So that's much better because when you do that, the forest around the pasture maintains a lower temperature, maintains much higher evapotranspiration. So that's better. But what I'm saying, I mean, to save the Amazon, we have to abandon at least 50% of the pasture and let the forest regrow. What I was explaining, in many areas highly deforested, we have to reforest because you saw natural regeneration is beautiful. This is the nature-based solution. But when you have 30 kilometers from distant from the forest, then the natural regeneration is very slow, because the birds, all the animals taking the seeds 30 kilometers, they don't. So that's why I'm saying for the Amazon, we need at least 56% has to be reforestation. The project that Brazil has, Arc of Restoration, requires a large 73 species, native species. So I think that's the solution.
So what can people do both in Brazil and around the world to help the odds of reforestation happening in the Amazon?
Well, first, of course, ecosystem services. Currently, unfortunately, only there is carbon ecosystem services. People don't see the value of maintaining biodiversity, and also all the Amazonian countries in South America, not only Amazonia, the recycling of water, the so-called flying rivers, is fantastic, even for the agriculture in other parts of South America. But at least for the carbon markets, now forest restoration has a tremendous also economic impact, carbon markets. So everybody globally, we should say, I think European Union is absolutely correct saying, well, we do not buy any product exported to European Union from the forest areas January 2021.
Would the main product be soy or beef, or there are other products?
Well, from the Amazon, from lowlands in the Amazon, is mostly soy, grains, and beef. So, that's very important. That's very important. But the more important challenge is the fact that the economic potential of what we call a social bioeconomy of standing forests and flowing rivers. That means the economic potential of using hundreds of products from biodiversity is much better than livestock farming. For instance, we run a study showing profits of agroforestry systems existing. It's not a future projection. Existing is $300 to $700 per hectare per year. There are some cooperatives there selling more than 50 products of the forest, maintaining the forest. This is not monocultures. The forest, agroforestry systems. The profits of livestock farming in the Amazon is very low, $50 to $100.
So economically, it could work out to value
Absolutely.
Ecosystem services,
Yes.
reduce the monoculture, reduce the deforestation.
Yes.
So what's the barrier to that happening?
The barrier is that as you look globally, beef consumption is increasing all over the planet. So, unfortunately, in the Amazon, livestock farming is the main driver of deforestation, the cattle ranches. And also, for our health, having many more products from the biodiversity is much better.
So if people around the world understood the severity of this crisis, and they don't live in Brazil, and they are busy with their jobs and trying to pay the bills, but if they made the one change of not eating beef, or especially not beef, well, you couldn't say not beef from Brazil because the soy is grown in Brazil and the beef is grown somewhere else. So would giving up beef make a significant difference on the deforestation of the Amazon? Full stop, that question.
Absolutely, absolutely. And IPCC, in many reports, has been saying reduce beef consumption. And IPCC was looking both reducing deforestation in the tropical forests, but also, as we know, the emissions of methane. The cows burp methane. So, yes, if we do that also, but also that would be very important for global consumers understand the potential of this new social bioeconomy. Hundreds of forest products.
I don't eat beef anymore. I don't eat pork. The reason that I gave up pork long ago, 15 years ago, is my girlfriend was a vegan, and I love dogs. So I imagined in my mind that a truckload of pigs going to be slaughtered was dogs. And it made me so sad viscerally that I never ate pork again. But I'm just wondering if hearing your story and hearing the urgency of what the Amazon tipping points mean for the world. I mean, I'm not advocating this. I'm trying to describe the science, but this actually is part of the science. If people viscerally imagined when they're eating beef, they pictured some hectares of the biodiverse rainforest going up in flames or something like that.
Right.
If that wouldn't emotionally trigger some discipline or behavior change.
It should. I have to tell you my story. I'm not eating beef for 17 years. Like myself, or like most Brazilians, eating, barbecue is such a tradition thing in Brazilian culture. So I was in 2007, I was giving a talk in a university in São Paulo. And then I show slides with the driver of deforestation, a cattle ranch, the cows. And then a student raised his hand and said, "Professor, do you eat beef?" And I said, "Yes, this is tradition. Barbecues. My wife, makes these barbecues every Sunday." And he says, "Are you sure the beef that you're eating is not from the Amazon deforestation?" I said, "I don't know." The next day, I went to supermarket where my wife purchased beef. I asked, they did not know. They asked the supermarket manager. 1 week later, the manager told me, "I'm sorry, we do not have traceability of our beef." I stopped that day because, that's, beef is the main driver of deforestation in the Amazon. And I fully agree with you. People should understand 65% of all tropical forest deforestation is for cattle ranches. So please stop eating beef.
What other recommendations do you have for listeners who are becoming aware, maybe at the 11th hour of our ecological plight? What other advice do you have for the people?
Please support Amazonian countries to save the forest, the largest tropical forest, the largest biodiversity, also with fantastic indigenous communities, other local communities. It's interesting because the Afro-descendant communities, they were for 300 years slaves. They were brought from Africa to the US, to Amazonian countries, South American countries. And then at one point in Brazil, mostly in Brazil, but also in Colombia, they, still slavery was there, and they abandoned, and then they went to the forest, to the Amazon forest, and they start creating their communities, Afro-descendant communities. It's very interesting. They learn with the indigenous people. They never did any deforestation. It's interesting because as slaves, let's say in Brazil, they were, the Portuguese were asking them to do all the deforestation. So they went to the Amazon, created a very large number of communities. They learned with the indigenous people, always maintain the forest. So it was, we really, we have to move in that direction. And indigenous communities in the Amazon, they arrived there 14,000 years ago, always maintain the forest. We know they use 2,300 products, 1,400 medicinal plants, 250 fruits. It's fantastic.
How many indigenous people are there now in the Amazon, and how does that compare to long ago?
Yes. When the Portuguese and Spanish came to the Amazon, there were about 8 to 10 million indigenous people. There were something like 1,300 ethnic groups, 1,000 languages, and always all these communities maintained the forest. And then, of course, it's very, because the assassination that they did was not really shooting. No, it was mostly with virus.
Yeah.
Europeans brought virus. And the Portuguese, mostly a measles virus was the main one. Oh, no, you wouldn't believe, out of these 10 million people, uh, in the there in Brazil by 2040, 2050, there were only 50,000 indigenous people. Only 50.
1940, 1940.
Sorry, 1940, 1940. So now, fortunately, in the Amazon, we have already 2.2 million indigenous people, much less than when we came,
Right.
the Europeans came, but still growing. They are having an average of 3 to 4 children
So
per.
they have a high fertility rate. Are they still, is there any research showing that they're continuing the traditions of protecting the forest?
Yes, they continue the tradition. By and large, 95% of indigenous people, they want to continue with their tradition, with their knowledge. Only 5% did the other way. However, so 95%. So now we have to learn a lot with these indigenous people. And unfortunately, it's increasing the population now. Unfortunately now, most Amazonian countries, they want to title new indigenous territories, etc. But listen, the big challenge in my country, Brazil, the new government, the new Minister of Environment, Marina Silva, for the first time in history, we have a Ministry of Indigenous People. Her name is Sônia Guajajara, an indigenous leader, a woman leader. And now the agribusiness in Brazil, they want that we do not title any new indigenous territories. They're totally against. So we have this political battle in Brazil. Government wants to increase tremendously the indigenous territories. The agribusiness continues with their dream, like like the Portuguese, expanding cattle, expanding soy, expanding agriculture.
So what is your work? You're doing bioeconomy. What is your main project now to stem these trends and reverse them?
Yes, I was, for many decades as a scientist looking at the tipping point, the negative tipping point. And I was saying, well, we are very close to tipping point, very close to tipping point. And then starting 2019, 2020, I said, well, almost 40 years of my career working only about the negative tipping points. Then I decided to, the rest of my career, to try to advance on positive tipping points. So basically, we are doing several initiatives now. One is, it was my suggestion to Brazil's Development Bank for the Arc of Restoration, this 24 million hectares of restoration. But also I created the project called Amazonia 4.0. So we want to demonstrate the feasibility of doing capacity development of Amazonian communities to do value adding bioindustrialization of forest products. So we create a laboratory for value adding to the cocoa value chain to produce chocolate. And also there is another product people know more in Brazil, that's not much exported. It's a close relative to cocoa. Cocoa scientifically is Theobroma cocoa, and there is another one that's called Theobroma grandiflorum. It's a beautiful fruit. In the indigenous language is cupuaçu. They also can produce a fantastic chocolate, and also a lot of the pulp. Also, the fruit is fantastic. So we did capacity development of 2 communities already, and we are starting to construct a biofactory for one of these communities to produce chocolate of those 2 species. And also we are going to do a capacity development for the first time in Brazilian history, now in November, December, indigenous community. There is an indigenous community in southwestern Amazon. They are known as Paiter Surui. This is a sad story. In 1969, there were 1,800 indigenous people in that community. They had very few contacts with people. 1969. And then the Brazilian government was starting a road there. And one person there working in the road went and contacted them and that person brought measles. Out of 1900, only 280 did not die, almost extinct. So this is a community. They are producers of cocoa. Now we're going to do capacity development. They want also to have a biofactory to produce chocolate. So this is Amazonia 4.0. And also we are planning now also one of these laboratories for Brazil nuts. Also for genome sequencing, we design a laboratory to go to Amazon communities, do capacity development for them to do the DNA sequencing of plants, animals, but also microorganisms because of risk of epidemics and pandemics. So that's the idea of the Amazonia 4.0. And also part of the Amazonia 4.0 is we want to develop in the Amazon the so-called Amazonia Institute of Technology, AMIT. I did my PhD at MIT. The idea would be to have in the Amazon an institute, quality of MIT, for this new social bioeconomy. Doing capacity development, undergraduate, graduate. We are finishing the design. We're going to release now 28 to 29 of November in the Amazon, in Manaus. 25 advanced laboratories, many courses. So we want to get funding. We estimated the cost for this is $400 million, but this is pan-Amazonia, not only in Brazil. And we want to have 1,000, 1,500 students per year, undergraduate, graduate students. So that's also, I would say, my last project in my career, to construct the Brazilian MIT, the Amazonian MIT.
So let me summarize, or attempt to summarize. We are close to tipping points in the Amazon and the world's stability from the Holocene. We need to stop the deforestation in the Amazonian forest. We can do that, and we are doing that. It's slowing down, but we need to get to zero deforestation. One of the biggest things we can do is stop eating meat, stop eating beef unless you know that it's not from the Amazon. We need to change the economic model away from monoculture to incorporate the ecosystem services and the broader diversity of life and products. You mentioned cocoa. And then globally, we need to reduce our emissions because the emissions are creating tipping points that are outside of the control of the Brazilian people. And then new intellectual development and social development from the people in South America.
Thank you very much. Fantastic summary.
So I have a few closing questions, Carlos, that I ask all my guests. I might guess the answer that you were about to give us, but what do you care most about in the world?
I think, my generation, I'm 73 years old. My generation was the generation that science showed the risk for the planet. Climate change, all other changes, as the planetary guardians say, all the planetary boundaries, we are having a tremendous risk, not only climate, but biodiversity, water, fresh water, pollution, all those things. So, unfortunately, my generation did not do anything to save the planet. So I think I want to communicate with the new generation, particularly young people all over the planet. Please take the leadership. Don't do what my generation did. Really take the leadership and let's look for sustainable planet. Is it possible? Yes, technology today for renewable energy, we do not have to, 70% or more of emissions from fossil fuels. Also regenerative agriculture, much less emissions, maintaining the biodiversity. So I have really to say, please, new generation, do something. But my generation did not do it. And you see emissions are still increasing in the planet. So I would say that's my message.
If you had a magic wand and could do one thing with no recourse to your security or reputation, what is one thing you could do, even if it was magic, to improve human and planetary futures?
One thing that I will do, because I love the forests, the tropical forests, and I love the Amazon, I would say, let's save the Amazon. Let's tomorrow zero deforestation, and let's restore all the forests. Let's value the indigenous people, local communities. That's the love we all have to the Amazon.
Thank you for your time today and for your lifetime of work on these issues, Carlos Nobre.
Thank you very much, and congratulations. Very important podcast that you make, and I'm sure you are going to really motivate the younger generations to do something that my generation never did.
We find ourselves no less than at the precipice of a battle between power and life. So I will continue to try, and onwards, my friend.
Thank you very much.
If you enjoyed or learned from this episode of The Great Simplification, please follow us on your favorite podcast platform. You can also visit thegreatsimplification.com for references and show notes from today's conversation. And to connect with fellow listeners of this podcast, check out our Discord channel. This show is hosted by me, Nate Hagens, edited by No Troublemakers Media, and produced by Misty Stinnett, Leslie Batlutz, Brady Hyen, and Lizzie Siriani.